constant, and how to find the weight or the relationship between two weights at two different locations. The second topic. The second topic is very related to this and will be the acceleration due to gravity. How can we calculate universally the acceleration due to gravity? Acceleration due to gravity. We learn, and this is what creates the gravitational field. So also it's called gravitational field strength, the same thing. Due to gravity or gravitational field strength. According to Faraday, Faraday defined a field with the definition he defined as a field is a function of value that depends only on the spatial coordinate r or x or y. So what is the meaning of field? So it's a function that if we have here, let's say this is the Earth, at this location we will have the same gravity. So if we go to here, this function will depend only, if it's a field, will depend, in this case the gravity, will depend solely on a spatial coordinate, space. In this case the space coordinate will be r. So this function will depend only on r. And that's what we call field of value. So here we will have another value. Here we will have another value. So but at the same r, we have the same value. At this r, we will have the same value of points. So this creates the same contour line with the same field numbers. And that's what we call field. So when you see in the forecast of the weather, sometimes you will see the pressure value that they give, that this is the same isobars here. And here's another contour line. Those contour lines are field that have the same value at a certain point. So in this case will be the gravity. When you study the electric field, you will learn what will be the electric field strength, that at a certain distance will be the same electric field. But now we are talking about the gravitational field. So we want to find the gravitational field. How can we find it? Very simple. We go to the main statement. To understand gravity again, you have to know that this equation or this statement. So if we want to find the gravity, we compare this equation with this equation. And from here, you can see that G, which is mg, is equal to negative gmm over r squared, r. So if we want to find the gravity, mass of the satellite cancels out. So G, as a field, will be negative gm over r squared, r. If we want to get the magnitude, that's it. This is the definition of acceleration due to gravity or gravitational field strength universally, not on the surface of the Earth. What is on the surface of the Earth? 9.8. So if we go to here and we want to find this G on the surface of the Earth, you have to substitute the value here, right? If we want to get at this point the radius of the Earth, the mass of the Earth, and the object is here, as we can see, the gravity only depends on the spatial coordinates since the mass is constant. G is constant. So the only thing on what depends is on the R. Doesn't depend on the mass of the satellite, depends only on the mass of the Earth. Why the gravity is the same for all of us? What we are in terms of central mass or satellite, what do we are? What are we? The same distance from the center of the Earth for the most part. So what we are? Satellites. So basically we are satellites that we are orbiting with respect to the center of the Earth. Why the gravity for me is the same than for you? According to that formula. Because the gravity is irrelevant or independent of the mass of the satellite. Everybody can see that? So on what depends the gravity? On the mass of the Earth is the same for all of us. And the distance that we are from the center of the Earth is the same for all of us. So the gravity is the same for all of us, which is 9.8. How can we find it? G, 6.67 times 10 to the negative 11. Newton times meter square over kilogram square time. What is the mass of the Earth? In average, 5.98 times 10 to the 24 kilogram. Divided by the average radius of the Earth. The average radius of the Earth, so if we